Alright, I want to do a quick little 10-minute video on G protein coupled receptors. Then the three different types: there's G stimulatory, G inhibitory, and then GQ. Y'all should already know what adrenergic receptors are. Remember, that's anything alpha 1 or 2, and then beta 1 or 2. And those are G protein coupled receptors. And then the cholinereceptors. Oh my god, let's just hope this works. Keep recording. Sorry for the cuss word last video. It's been a little frustrating to get this set up. But the cholinereceptors, anything that responds to acetylcholine. There's nicotinic and muscarinic. And these mechanisms, remember, are very different. Nicotinic is ligand gated, and then muscarinic are G protein coupled receptors. Okay, so adrenergic receptors, muscarinic receptors are G protein coupled receptors. That's really important, the difference. And then nicotinic receptors are ligand gated receptors. But remember, nicotinic and muscarinic both respond to acetylcholine. Okay. This picture is just an example of why are we looking at G protein receptors? Because they are coupled to receptors that respond to a lot of different stuff, and you'll learn each of these mechanisms and substances in medical school, but this is just an example of the complexity. You don't have to know anything from this slide, but just appreciate the complexity of what they do and contribute to. As a general mechanistic overview, there's basically a G protein linked receptor, and it's also called a 7TM receptor because it traverses the membrane 7 times. And that is, in inactive form, there's a G protein coupled to a GDP kind of sitting right beside it. And then there's an enzyme sitting over here. When it's activated by the signal molecule, for example, norepinephrine or acetylcholine, or anything you saw on that previous slide, this GDP is displaced by GTP. Now they come together, bind, we have active G protein, the active G protein displaces and then goes and binds this activated enzyme, activates the enzyme, and we have a cellular response. And then after everything's done, we have a displacement of the signal molecule and a return to inactive form with the GDP. So just active form, GTP is bound. Just remember that. Okay, let's talk about G stimulatory first. When the receptor is bound by its ligand, this process takes place, and we get an activated enzyme. And in this case, the activated enzyme is adenyl cyclase. And adenyl cyclase causes the conversion of ATP to cyclic AMP. And then there's an activation of protein kinase A. There's changes in gene transcription, upregulation of transcription factors, all kinds of stuff that goes on. Just keep in mind, just things to remember, anytime you see increase in cyclic AMP, think increase in calcium. And that's not always a hard and fast rule, but it'll help to remember because we talk about the different muscle types. Remember, calcium means contraction. When we're talking about GI, G inhibitory, all it is just the exact opposite of the GS. So when the receptor is activated in the case of a GI, there is an inhibition of adenyl cyclase, and because of that, there's a decrease in cyclic AMP. So that's all you have to remember for that. Anytime you see cyclic AMP, think calcium. GQ is the different one, and that involves a enzyme called phospholipase C. Phospholipase means it's splitting apart phospholipids, right? In this case, it splits apart this chemical here, PI45B2, into DAG and IP3. DAG and IP3, DAG and IP3. And then there is an activated protein kinase C. You get a release of calcium, usually from endoplasmic reticulum. And if this looks familiar, it's because this is a lot of the mechanism of smooth muscle contraction. Because remember, calcium contraction. In this case, the calcium is coming from here. And a lot of the smooth muscle receptors that cause contraction are linked to a GQ protein. These next two slides I got from Dr. O'Brien. They're a really good review, just to keep everything in perspective. I like it because it gives an example of each type. So an example of a GQ is alpha 1. And remember I talked about the last slide, smooth muscle. Increase in calcium, smooth muscle contraction. So that's a big example with that. An example of a GI coupled receptor is alpha 2. And remember, GI is the opposite of GS, so it inhibits adenyl cyclase. And this is probably the big one to know for this, because pharmacologically there's something called clonidine. And clonidine is an alpha 2 agonist, and it acts centrally. And what happens when the alpha 2 receptors are stimulated? Centrally, there's a modulation of sympathetic outflow to where actually sympathetic outflow is indirectly decreased. Example of GS, definitely know this, right? Beta 1, love beta 1, it's in the heart. And when that's stimulated, you get an increase in cyclic AMP, and you get this, right? Test question. Okay, another example of GS is beta 2, and that is in the lungs, so that's also important to know. Bronchodilation, because remember this is sympathetic. I think that's all I really want you to know from here. On the parasympathetic side, remember I said muscarinic receptors are G protein coupled, M2 in the heart, TQ. M2 coupled to GI. This makes intuitive sense, which is why I want you guys to learn it, because acetylcholine decreases the heart rate, inhibitory, decrease everything, decrease adenyl cyclase, decrease cyclic AMP, decrease calcium, decrease heart rate, decrease contractility. That part just makes sense. Parasympathetic, rest and digest. Opens the potassium. I don't know how to fully explain that, so I'm not going to. Don't worry about it for now. M3, if you remember, M2 is in the heart. M3 is like everywhere else. I mean, if you look at all this stuff. So if you're ever in doubt, the organ is not the heart. It usually has an M3, and M3 is coupled to GQ. Okay. So this YouTube channel was one of the gold mines I found studying for boards. It's called Dirty USMLE. And it just, FYI, it is some of the mnemonics are very dirty, especially ones in this video, but he does a good job explaining the pathway, and you'll probably never forget his mnemonics. And the mnemonics in this video and in the next slide are to remember which receptors are coupled to which G proteins. This is the second mnemonic. The GI are the MAD2s, and I put it in red because it's inhibitory, and M2, alpha 2, and dopamine 2. Don't really have to know that for now, but it's useful for later. So muscarinic 2 and alpha 2. GI, inhibitory. GQ, have one M&M. Have 1, M and M. The M's represent M1 and M3. The halves stands for histamine 1, alpha 1, vasopressin. These are the ones we talked about today. And then if you memorize those, you know that all the rest are G stimulatory coupled. So that's probably the best way to remember it. And you guys might be thinking, like, why is this important? There's a lot of drugs that target every step of the pathway of intracellular signaling. And a lot of that is related to G protein coupled receptors, and for that reason, they really like asking about that. This is a good Khan Academy video about G protein coupled receptors. I put a couple links here because I know this is a tough topic, so to help get some other material reviewed from other sources. It's just a good summary table. I like it because it has everything. For instance, it has the action, it has the receptor, and at the different organ systems. These are your learning objectives, and that's it. I hope this recorded. We'll find out here in a second.